Okay, I think that they have been successful in restoring the media. Can people hear me?
I can hear you.
All right. Well, they've been successful in restoring the media stream, but I still cannot show slides yet.
Ross, I see the slide.
Okay, I think we have the technical issues sorted. What I was unable to upload from the data tracker, but I was able to upload from my desktop. So we now have the slides. We now have audio. It appears we have video. So I think we're able to get going here. We do need someone to take minutes in the Cody MD. Can I have a volunteer to do that? Deb did it last time. Let's pick on somebody else.
I mean, Russ, I can do it. I haven't done it before, but I'm willing to volunteer. It's John Gray.
Oh, all right. Thank you. I appreciate that. You can find a link at the top with the little pencil in it
Okay.
to open the page where we can take notes. All right. Thank you.
No problem.
All right. So a reminder that this session is under the IETF Note Well. So if you're going to contribute, please make sure you understand your rights, privileges, and responsibilities. And the agenda for today is really kicking off the whole post-quantum portion of the LAMPS charter. These A through H are listed here as the milestones that have some PQC related activities. Is there any agenda bash? Okay, Tim, if you would watch for people raising their hand and such, I will run the slides and I think we'll be good that way. Right, thanks. So I'm going to change slide decks, and Mike has prepared a set of slides to raise each of the points that need discussion. Okay, Mike, if you would come to the microphone.
Is this at the microphone?
You are.
Most wonderful. All right. We've made a couple minor tweaks to this deck since I sent it to you, so I'll just maybe highlight where we've adjusted stuff. Yeah, next. So my thought for today was to go through the LAMPS milestones as they're set out in the charter. I'm going to present them in a slightly different order, Russ, than you had them listed, and then that the LAMPS about page has them listed. There's a bunch that are all due in December, and I think they're sorted alphabetically. I've decided that clustering the chems and then the signatures is a more logical presentation flow.
You know what? A outcome that comes up with more realistic milestones is also welcome.
Yeah, that's fair. And then the second half, time, I think the milestones is where is the point of this meeting, but time allowing, we have prepared slides. We have 4 fairly mature drafts that we think accomplish the hybrid key establishment and the dual signature milestones. So time allowing, we would like to, continue to raise awareness that we think those meet the milestones. But milestones first. So, yeah, next. Yep. Next.
Sorry,
so here they are. I pulled.
Sorry to just break in. I'm trying to take notes, but it's not letting me into this hedgehog thing. Is it okay if I just use a text editor and then figure out how to get it into the right system afterwards? Sorry to interrupt.
Sure. Just send it to me at the end of the session and I'll paste it in.
Okay, thanks, Russ. Sorry to interrupt.
Thanks, John. Thanks for taking notes. Okay, so here are the milestones as laid out. We have one in October, which is coming up real fast, and then the rest in December, which is also going to come up real fast. The first one is about chems, so adopting a draft for post-quantum crypto chems in CMS and PKIX. And then lower down, we have Oh, I didn't adjust the order of this as much as I wanted to. That was a change we made it later. So then we have hybrid key establishment in December. We have choosing primitives for signatures in December, and we have dual signatures in December. So let's go into the first group, those 2 Octobers. Next slide. So the work here, as I understand it, is to assign OIDs and define encodings for the Chem algorithms that are coming out of the NIST competition. Presumably, we're taking the NIST candidates. I assume that's what's driving this, rather than generic chems or chems from other sources. So
well, the charter says that we will take either NIST or CFRG vetting for algorithms. So, given that none have been presented as alternatives to the CFRG, they're not going to happen by the end of the year.
That's a fair point. So then so what does this milestone mean? Adopt a draft. Clearly we need to wait for CFRG, clearly question mark. We need to wait for CFRG to mint some chem algorithms for us to use, question mark. The LAMPS working group's job is to assign OIDs and figure out how to pack them into ASN1, I assume. And then the third bullet here is one that we've really wrestled over is, how do these even fit? And there's a fourth bullet I added later. How do these fit? Chems, they're not really encryption because you're not taking a given content and encrypting it. They're sort of more of a shared secret derivation. They feel a bit more key exchangey in that you run the chem and a shared secret falls out. So they're not really encryption, but they're not really key agreement either because only one party has a public key. So they don't fit the CMS key agree recipient info structure or API. So I've got here for CMS, do we need to define a chem recipient info that's structurally and behaviorally different? The same question comes up with X509. I think people have been putting chems in a key encipherment key usage, but it's not totally clear that that's correct. So do we need a different key usage? Like, I think those questions are should be part of this, what it means to define chems for CMS and PKICs.
So when we were starting to work on the charter, the reason these dates appear before we knew NIST was going to make a publication was to address exactly the questions you're raising right now. Do we do a chem recipient info for CMS, or do we mash it into key agree recipient info? Those are kind of the choices. Define an other or find a way to mash it into key agree. And likewise, I personally think that defining a new key usage is going to be hard, but we may want to combine it with a extended key usage, which is easy. And as Jonathan Hamill pointed out, when RSA KEM was done, Bert Kaliski and Jim Randall decided to mash it into key trans recipient info. In some ways it fits, right? Because of the one-wayness of it. The one party having the public.
Yeah, Russ just said what I was going to say, but yeah, I think they've essentially defined how you use a chem to create a key encipherment, and then it fits well. And so we could follow that model, or it really depends whether we want to expose the pure chem functionality directly or whether we're okay to just expose the encryption scheme that they're using.
Okay. So I think that defines the work. I mean, this is all, do we need to come to an agreement on this call, or we just need to acknowledge that these milestones is not just about choosing algorithms and putting OIDs on them. There's some structural decisions to be made here.
Mike, you had a hand. Do you want to deal with it?
There's a hand?
But just a slight comment about does LAMPS need to wait for new PQC algorithm? But just we have to keep in mind that the standardization process at NIST is going to end, well, at least partially soon. So new algorithms are going to be defined by the beginning of next year. So
Is that true? Does that mean there'll be fully specified documents by beginning of next year, or that
no.
they are beginning the process of writing standards beginning of next
Well,
year?
at least you will have only to deal with one algorithm, so you will know the name. And so, of course, it will take 1 or 2 years to do the specification. But still, at this, well, you will have only one algorithm to deal, and so it's only in a few months.
So my understanding, Russ, of the process here is the milestone is adopted draft. This isn't finish a
Correct.
draft. This isn't working group last call a draft. And so I've sort of cheekily got my second bullet down there under status. Should we is meeting the milestone mean choose an author, throw up a more or less empty 00 document, and then at least we have a place to be bashing this? Like, is that what the milestone is calling for?
You have another hand. Scott, go ahead.
If NIST announces that, say, Falcon is going to be the winner, it's not clear if they are going to go with the parameter sets which are defined within the round 3 Falcon draft, or they'll be a little more conservative and have slightly larger more conservative parameters. So,
Right.
well,
Even if they're the winter, they may still be tweaks to the parameters.
yeah. And so we have to account for that possibility. Thank you.
I think that's true on any of the candidates, but especially likely with that one. You've got more hands. So, Yov?
Yeah. Can you hear me?
Yep.
Okay. So, well, I don't think it's any bar to adopting a draft that the parameters may change. I mean, our process takes 1 or 2 years, just like their process. It's not like we adopt a draft in December and publish an RFC in March. So I think that the possibility that parameters are going to change is certainly no bar for adoption.
Okay. Yuri?
Concur with Yoav. Second, a very naive question. Why is this even a concern? Whatever NIST blesses by the end of January will be a CAM with a very fixed interface. Who cares what parameters exactly will it have? And why? That can be dealt easily with OID, with just assigning the appropriate OID to a specific algorithm plus parameter set. Everything else does not need to be changed, regardless of what NIST says. So there would be a separate definition of how to implement a post-quantum CAM algorithm. And this draft would just say, take the algorithm, whatever the OID in the received message prescribes, and invoke decapsulate. Take whatever you retrieved and process in the following way, and define how to derive actual decryption key from what you get from CAM. Why should it be more complicated than this?
Go ahead, Tim.
Well, so I was just going to answer Yuri's question. I think Yuri's mostly right. The reason why it's slightly more complicated is because some of the parameter twiddling may impact some thinking we do about performance trade-offs or sizes or things like that. Some of that may change underneath us as we're working on things, and so that may influence some of our choices. But to Yoav's point, there's plenty of time for us to adapt to those sorts of changes, and if they do impact some of the performance analyses or other things like that, and that does cause us to go down a different road, we have plenty of time to do that. So I think Yuri's mostly right. We can ignore the details of the algorithm until we can't.
Go ahead, Yuri.
We need to take performance into account, because whatever NIST defines, slow, fast, it will be what it will be. And if decoding a CMS message takes longer with a certain algorithm or shorter, that's the fact of life. I would not change anything based on performance of a given set of parameters.
Tim, is that an old hand?
Old hand.
I don't know. We'll see how it goes. I suspect that that's going to turn out right. That none of the parameters turn out to meaningfully impact any of our analyses in the event that there are changes. But I don't think it's impossible. So I think it's something we should keep an eye on.
So my view to the question that Mike has put on the slide is one approach to starting this work would be to take the approach that was used in the RSA Chem and see if it fits well with the candidates, and if so, post that as a draft and put it forward for adoption. Yuri? Okay, back to you, Mike. It looks like the queue's empty.
Okay. The last bullet of the status, we need a volunteer author. Stuff doesn't tend to move forward if no one's working on it. How do we get someone working on it?
Well, we're going to ask for volunteers, but I think we should see what the list of volunteers we need is going to be, so that people know what the whole dance card looks like before they volunteer.
Yeah, fair. And I just want to raise Roman's comment in the chat that milestones are needed for charting. We can easily slip a milestone. Let's not rush. Okay. So that sounds like a decision to me. We're not overly fussed about which algorithms or which parameters at this point. We're not trying to get the ASN1 encodings polished. This milestone is more at this stage about defining the container formats. Okay. Next slide, please. So now into the cluster.
We have a new hand. Let's make sure it's about the old topic. Yuri?
One encoding. It appears that it would be counterproductive to try to improve over what NIST candidates are already doing. That means ASN.1 encoding will be octet string, period. Anything more elaborate or more complicated, in my opinion, would be highly counterproductive.
Yeah, I'm not trying to suggest that we re-engineer how the public keys or ciphertexts are carried, but I mean parameter sets or OID encodings, or which ones need parameters, which ones don't. How do you package? Yeah, I don't know. There's going to be stuff to do for sure.
Okay, let's go on to the next slide.
Okay, so I've grouped here, because it sort of feels like it flows to me, the hybrid key establishment as the next logical step after Chems. So assuming we know how to do Chems in PKIX and CMS, now we want to do more than one of them at the same time. And I apologize, the font is a little bit small. So the milestone here, as I see it, is the working group hasn't, I think, really decided what overall direction. Russ and I have presented back and forth a few times on multi-cert versus some kind of multi-key. Composite is one example of multi-key. There could be other types. We've recently completed a composite encryption draft that leverages our composite keys. So we wrote composite keys to service our composite signatures, but we've generified it and written a composite encryption that we'll get to if we have time at the end of the slides that implements the CMS key trends stuff. So there is a draft submitted against this milestone. It'll need probably quite thorough CFRG security review of the combiners here. Russ, do you have thoughts on the progressing this one forward? Is this one okay to sit for a while?
Well, I think that this is a example of a way forward. I think there's kind of some choices, as you already talked about, two different ways to do. You have two drafts in this space for the way to do this. And I think we need to get one that the group likes, and then we ask CFRG to take a look at it if it doesn't use a combining approach that they have already looked at.
Ludwig?
It's just one question about the philosophy of the different draft that you wrote. So you have composite, explicit, composite keys, composite encryption. Can you quickly explain the difference between each of these drafts?
Yes, we actually have slides later on. If you don't mind, I'd like to get through we're at half the time through the meeting here. I'd like to get through the milestones first, and then in the slide deck, you can download the slide deck and scroll forward if you want. We do have slides explaining our draft, but I think we should get through the milestones first. I think that's the more important use of time here.
Okay.
Okay, is there anything else to say on this slide? I guess that whole discussion on direction and design choices needs to be facilitated. I see your point, Russ, that we've sort of taken some decisions and made an example draft, but if that isn't the direction, then these drafts wouldn't apply or need to be reworked.
Right, and I think we just start that discussion on the list. And, if there's agreement that this is a reasonable way forward, then we do the adoption.
Okay, so that's a discussion about sort of at the highest level how to perform hybrid key establishment.
Yep. Well, I mean, you've got a full written proposal here, so that's a great way to start the discussion is, hey, look at this draft. Do you think that's a good way?
Right.
I mean, the alternative would be to adopt the draft and then completely rework it if people felt that there was a better way.
Procedurally, adopting a draft does get it time at 112, right?
Yep. But I would like to know, if whether people think this is a reasonable way to proceed, so as to not spend a bunch of time on process of adopting and then fighting that, no, that isn't what we want to do.
All right. Well, so for that vein, then, for those 33 people on the call, the draft is up. This slide deck has a English language brief explanation of the approach of the hybrid key establishment, hybrid content encryption mechanisms. Yeah, feedback welcome. Okay, next slide. Yuri?
I'd like to ask how strongly people feel about the need for hybrid key exchange, because it appears it would be useful in only one case, if quantum computers do not become cryptographically threatening, and post-quantum algorithm fail to classic attacks. In all the other possibilities, that would be just an extra burden. I personally, based on my expertise, whatever it is, believe that it is an overkill that adds very little usefulness.
And so, yes, quickly commenting about this remark about the usefulness. So there is one reason, maybe it's not a good one, but I mentioned that, is that for certification of security products, which are going to be based on the protocols that we are deploying. So the trend is that all security agencies will require to have a hybrid mode to make the certification. So if you have not a hybrid mode, you will likely be difficult to certify a product with PQC. And so another thing that I wanted to say about hybrid key exchange, so there is various groups that are dealing with this issue. So I think TLS is discussing of that. I think the group on IPsec has some discussion on the topic. So probably it could be at some point good to synchronize all the things, even if there is slight difference at the end. We want to do an hybrid key exchange.
Okay, I put my hand up. So speaking without the chair hat, I think there's going to be a fair amount of time in transition that's going to require people to get comfortable with the new algorithms and the implementations of those algorithms. And so hybrid offers a way where the classic algorithm provides kind of a safety net for those people as they develop comfort. And the cost of doing a classic algorithm, if you're doing a PQ algorithm, is pretty small.
Computational, which indeed is small, but overhead with the extra code that requires extra validation, this kind of things.
Mike,
I
go
have
ahead.
thank you. I have two points. So then another need, I think, that drives hybrid is, and this is a bit of a fear and doubt argument as I make it, but RSA is very well established. Where there's been lots of CVEs in and implementation bugs that everyone needs to scramble a fix for, but it's fairly old, fairly mature. I expect this new stuff is going to have to go through the same wave. I expect it'll be a decade before it's really done having CVEs in it. Hybridizing it with RSA gives us that security that a CVE doesn't leak your data. Second argument I want to make here is within the context of CMS, hybrid content encryption. I am sending you an email, here it is, and the recipient has multiple keys, and therefore the email is protected by multiple algorithms. That is, I think, structurally different from the hybrid key exchange that TLS and IPsec are working on. So I do think we have work here that's distinct from what the other standards, what the other working groups are doing.
Okay, I don't see any more hands.
Okay, so then to this slide, which is signatures. So this is very similar to the first slide, although it's a lot more straightforward how this is going to fit. Signatures are signatures, signature key usage, signature structures, signatures are signatures. So this is a much simpler slide than the analog for Chems. But I guess the work is similar in that we need to start specifying algorithms, or how does the work for this one differ or compare to the work for Chems?
Well, I think it's much simpler because we don't have to worry about should we be using recipient trans or recipient agree and stuff like that. And I think it's a matter of just taking the OIDs that get assigned and stating what the conventions are for use of parameters and be done. Once we know what the algorithms are. You could write a placeholder that says, insert name of algorithm here, insert OID, but I don't see that as particularly time consuming to then, just wait until the winners are named and then we can insert the OIDs once NIST assigns them. I think we wait on this one for NIST is what I'm saying.
Okay. Give a second for hands on this slide before moving on to the hybrid dual version of this slide. No hands. Next slide. So this slide is very similar to the one above for key exchange. Assuming we have PQ signatures, then we are going to want to layer them. The word here is dual. By the way, I meant to mention this a couple slides back. The word hybrid key exchange, hybrid encryption is already a buzzword, right? That's the AES plus asymmetric. Hybrid key exchange, I suppose, is unique, but once we start talking about content encryption in CMS, I don't know what we're going to call it because the obvious word choice is already taken. Deal with that when we get there. So dual signatures. So us at Entrust and with Max Pala at Cable Labs, this was sort of the first one that we worked on, I think, out of Cable Labs' necessity to implement it quickly. So this draft is an 05, composite signatures. We've recently split out keys and explicit, both generic and explicit. So these are fairly mature. ITU has their X10, which does something a little bit, maybe if you squint at it a lot, like this. Although it uses ASN1 extension marks, which don't line up or aren't supported by the ASN1 modules in 5280. So this is one where there is already a fair amount of history here. I think LAMPS still sort of presenting slide bottom up, which is weird. LAMPS, I think, still hasn't chosen a direction, despite there being a fairly good body of work here. So I guess this is one that we also need to start a mailing list discussion and nail down goals.
I think it would be interesting for someone to present like a one mail note, pros and cons of the two approaches.
And when you say the two approaches, which two approaches?
The ones in your draft and the one in X510.
Okay.
I mean,
Are we
I have an opinion, but I've read them both. I suspect that's not true of the bulk of the people I hear.
Are you still considering, so those are both, the composite here and the X510, those are both what I would call multi-key, in that you're putting multiple keys into a single certificate. Are we still considering a multi-cert? Because that's still on the table.
Maybe that's a third dimension to suggest, but if you were to take that approach and have separate certificates, one for the classic and one for the post-quantum, right, which was something we discussed, I don't know, 6 months ago, you still end up with the multiple signatures on the CMS with just different certificates to validate back, different cert paths for each of the signatures. And Max had a bunch of reasons why he thought that was difficult in his environment anyway.
And I think there are strong cryptographic arguments to make that if you have dual signatures, you want that chaining all the way up to a single trust anchor. I think there are arguments to make. I think you're asking that I draft that and send it to the list.
Yeah, yes, I am. I don't think and I don't think it's a lengthy note, right? I do think it's like, a page or page and a half, something like that. I don't recall that there being a rationale section in your internet draft that said why you pick this over that. If it's there, just point to it.
Yeah, it's probably right.
Sergey?
I just wanted to ask, related to the X510 submission, so one of the points there is that I guess X509 has evolved a little bit and added the extension marks at the end of the X509 certificate definitions, but those aren't in the IETF profile of FX509 and 5280. And so I'm wondering if there's a history there, or whether this is something we'd adopt if we decided it was useful, or what's the history?
Is it that the extension marks are newer than when 5280 took that profile?
Yeah.
Is it as simple as that?
They were added in an edition after. I don't remember what one, but 5280 was written with the old ASN1 syntax that didn't even have extension marks.
Right. Okay, so it's not that we're explicitly not following them or something like that. Like it would kind of be the intent that, X509 still, we would pick up the newer additions to X509 in a revision of 5280 eventually when the need arises.
Well, as long as it doesn't impact interoperability. Sean?
Right.
I think blindly saying that we are going to adopt the 5280 extensions and changes they made is probably not a truthful statement. We might look at some of them, but it depends.
And I think you meant X509, not 5280.
I did. Sorry.
And in fact, we mean X510. Okay. So that again sounds like another call for mail list discussions. Okay, so that's then the bottom of my milestone slides. In the 13 minutes that are left, is it a good use of time to go through some of the design choices we're proposing in our drafts, or is that premature?
No, go ahead.
Okay, so skipping over a bit, can you go to, yeah, just go down a couple. Serge, I'm going to throw you into the ring here. Yeah, one more. So Serge, this question came up. What's the difference between our proposed or two different key drafts that are competing with each other? You willing to take this question?
Sure, yeah, so I can kind of give an overview there. So, yeah, so I guess we have what we're calling generic composite, which I would say is almost, it's what you would expect if you're a developer and you're creating software and you want it to be as flexible and reusable as possible. And so you can see the definitions here of the composite public key and the composite private key. They're just sequences from 2 to infinity of a subject public key info, or for the private key of a symmetric key, the corresponding private key object. And so if you have an instance of a composite public key, in theory, there could be absolutely any public key objects of any type in those containers. And then just for completeness, I'll mention, yeah, so that's the public key information object for PK composite. And yeah, it's exactly what you'd expect. There's another wrinkle, and this isn't not talking about explicit yet, but there's a wrinkle about as soon as you have multiple public keys that are being put together and treated as one, there's the question of, well, do you require the users to always use all the keys, or do you have some policy that says you only use some of them, or it's okay to only use some of them? And you could make that arbitrarily complicated. What the current draft does is it proposes, so by default, this ID composite key, that says you always use all the keys when you're using the key, and so if you're verifying a signature, you have to verify every single signature, and they must all be valid, otherwise the signature is not valid. There's an OR mode, which is identified. And so here we've chosen explicitly so we're defining 2 object identifiers for the different keys, so that the owner of the key essentially gets to say, is this a collection of keys that's used in AND mode or in OR mode? It's not the recipient or the user that gets to decide that. But in the OR mode, the primitives allow for only a subset of the keys to be used together. And so that's the difference between the AND and the OR. The generic versus explicit. So as I said at the beginning there, the subject public key infos that are in the public key list, they could be absolutely anything. And if you have a key object with the identifier ID composite key, that tells you nothing about what's inside. And so other aspects of how you're using this thing need to tell you what's allowed if there are restrictions. It's very, very flexible. And I think that can be a good thing or a bad thing depending on the circumstances. If you go to the next slide, I'll show the...
We have a hand up here. Do you want to take...
Oh, sorry. Yeah, for sure.
Elliot?
Very good morning, good afternoon to people. I just have one question about the AND or the OR mode, which I hope we can have some discussion either now or later, which is, do you or does anybody have advice as to when to use which mode?
Yeah, so we've been writing this with the idea, so Serge and I are within Trust, and John Gray, third author, and then Max from Cable Labs, and it's sort of two different design decisions, design discussions that are been shoved into the same draft. I think I'm imagining that for public PKI, like internet TLS, you'd want to always use the AND mode. For closed PKIs like Cable Labs, internal thing, or maybe a corporate SMIME or something where you have sort of weird migration requirements, but you're also more able to more tightly control the clients, that's where the OR mode might be useful. At least that's sort of how we got to writing it this way.
Okay, thanks
Go
very
ahead,
much.
John.
I might have more on the list. Thanks.
Yeah, I was just going to jump in quickly and say that the OR mode is good for migration as well. Like, so if you wanted to use one key, for instance, the classic algorithm, and then switch to a newer key like the PQ algorithm, but not have to update the end client software, like say it's out in the middle of the ocean somewhere. Well, obviously you have to update the software, but maybe not the key that's there. And you just switch in software which one is being used. So I've heard of that use case being used for OR as well. But I myself prefer the AND just because it's more secure and you know exactly what you're getting.
I'm actually wondering whether these belong as separate documents because the security considerations for the OR get super complicated.
Yeah, and
exactly.
to that point, we basically haven't specified OR. We've said we've specified very cleanly this is the AND behavior, and then we sort of have a paragraph that says if you want to do something that's not this, go use a different OID. Bye bye.
So yeah, if you just go ahead to the next slide, just so I touch on the explicit composite as well, because I think it's an important debate. So yeah, so in the generic composite, the container can contain arbitrary pairs of, or actually tuples of public keys. In the explicit composite, it's a much more rigid approach. So the idea is we're still providing, I almost say a framework, but a structure whereby pairs of algorithms can be used together, but those pairs are, the types of the pairs are fixed by the object identifier. So you can see on the left-hand side, and this is using, say, the fancy ASN1, the more modern ASN1, and I'm definitely not an expert there, but so I think on the left here you have the definition of the information object class, except I've left out the definition, but you can see the parameters that go with it. And so you can basically see you've got an object identifier, and this is going to bind it to a first algorithm, first public key type, and then a second algorithm, a second public key, and a second public key type. And then I give an example here just with toy, like this isn't actually like there is no OID named IDSA and Trust 4056 RSA and ECDSA, but this just shows how you would define an object identifier to represent the combination of RSA and ECDSA. And so this is quite different because now, an implementation that says, yeah, you can use this OID in this protocol, they're only allowing those particular, that particular combination of algorithms. The algorithm choices and the parameters that go with them, they don't need to be transmitted on the wire because they're all encapsulated in the OID, just as for a TLS cipher suite, right? You have all the parameters kind of reduced to an integer. And yeah, so it's a lot more, it allows you to be much more rigid in what you're going to accept. But it's still, because we're using the framework, you're still making sure that the way that the pairs of algorithms are encoded, the way the signatures are validated, etc., those are all specified once. And it becomes very easy to add a new pair to the list of supported combinations. And so I guess, yeah, there's a trade-off there. I think the generic one, actually, if you go to the next slide, there's a little bit on that. But so the generic one is very flexible, and I think it means as an application you have to handle all those cases, and it's more. There's, I think, more to go wrong perhaps, The explicit gives you something much more defined, where at least I kind of feel like, yeah, you really know, well, when you're allowing certain algorithms, you know exactly what people are going to be able to do. But there is a question. I don't know whether it's, do we need both of these? Do you need just one or the other? And then in the case of the explicit, who's going to define the pairs? Are you going to, is it CMS that's going to define them and TLS, or are we going to have a master list somewhere? And it probably depends a little bit on how many of these pairs there are going to be, which one is better. Like if it turned out that in post-quantum, there are all sorts of parameters that get used in practice, then having different noids for each one might be tedious. But if they're going to be a small number, then the explicit is more compact and more controlled. And I think control in general is good for security. So yeah, so that's kind of the generic overview.
So this is Russ. I am concerned with question 2 here. In the PKIX working group, the way to do algorithms was specified, but none of them were ever made mandatory to implement, because the feeling was that the application protocol that was actually going to use the certificates should make the algorithm decisions. Likewise, in CMS, different algorithms were specified, but none were mandatory to implement, because things that use CMS, such as SMIME, were specifying which algorithms were mandatory to implement. And choosing the pairing here seems to be essentially making those kinds of choices. And so I'm wondering why you think the LAMPS group is the right one to do that.
Yeah, I don't think I'm saying that. I think actually one of the things I like about the explicit spec is that we can, in LAMPS, define how to combine the algorithms correctly, and then adding an algorithm to a pair of algorithms to the list is not difficult to do from a security. Like everything's already defined by what would be the LAMPS RFC, and so I am thinking that yeah, applications could define the pairings themselves, and then but they would benefit, instead of having to write a long RFC with the encodings and so on, they get to use the building block that is the LAMPS explicit scheme.
Okay. Does anyone want to speak for the other approach? Okay, I think we have a decision on that one that needs to be confirmed on the list, but hearing no one speak for it, I suspect that's not an issue.
So sorry, Russ, speak on for whether we should adopt it. Is that what you mean, or not adopt it?
No, what I'm hearing is there's a desire to do the generic, but not the explicit.
Oh, okay.
Is that true, or is it the opposite? So you're saying there's a desire
That what I heard was no one speaking for picking the pairings in LAMPS. Go ahead, Tim.
But that's different.
So, what if my
Picking the
position
pairings
is,
in LAMPS is
picking the pairings is very important, and I'm agnostic whether LAMPS is the best place to pick them.
Fair. Yuri?
But I think that. Sorry.
we're
Vote for
picking the pairings in
picking.
LAMPS is different from whether we specify a generic or an explicit container format.
I think they should be specified. A container format is one thing that must be specified, and the pairings, I think, would be desirable to specify. I do not feel as strongly as about the containers, which seems very obvious. But explicit seems to have enough value to provide it.
I'm surprised to hear you say that, Yuri, because this is a way to implement hybrid, which you were speaking against.
I do not like it, but if people go with hybrid, then that would be the way, I think. I suspect it may be useful for other things as well, because it's not only what kinds of CAM you include. It could be what kind of key exchange with what kind of signature, and so on, or signatures.
Roman?
I don't have a technical opinion here, but I just wanted to remind everyone, this seems like a really important design decision. We're at time. We should probably just punt this to the list so we make sure we adequately capture the outcome.
Yeah, thank you, Roman. Yeah, I was kind of letting it run a little late since we had the Medico technical issues at the front. But, okay, so I bow to that wisdom that we'll pick this up on the list. At the same time, if we have a few minutes, I would like to know if we have some volunteers for the drafts we've identified regarding chem and hybrid. I'm assuming that Mike wants to keep working on the hybrid stuff. Sean?
Correct. For the chem one for the PKIC stuff.
Okay.
And so, in principle, also we would like to volunteer, but I have to think about on which document. But yeah, motivated to take some documents.
Okay. Could you tell us by email then?
Yep. Yeah.
Okay. And we also have some post-quantum signature documents, which we thought we know we have got more time on. We said, let's wait for NIST, but people who want to author should be thinking about those as well. Okay, since we are over time, is there anything else someone wants to raise for the whole group before we shut down?
If you can quickly flip to slide 15, I'd appreciate that just being shown. I'll just try and take 15 seconds here. For the composite encryption and key exchange draft, we've proposed 3 different mechanisms. One that uses only encryption primitives, one that allows you to combine encryptions and chems, and one that allows you to combine key exchange encryption and chems in increasing complexity as you go more and more generic. And we've designed this to fit with CMS. Would love to throw that out there for thought whether this is a good approach or not.
And which document is this in?
This is composite encryption.
Okay, thank you. I don't see the details here, but I was kind of assuming that you would do multiple key establishment techniques, put them into a KDF together and result in one key that is then used, but you're not doing that.
That is option 3. So option 1 was, so option 3 does not allow you to specify a content encryption key. That mechanism, what you're losing is you can't already have an AES key. So if your document's encrypted once and you want to distribute copies of that AES key to each recipient, then what you described doesn't work. or you need an extra layer in between. So method one says if you have multiple encryption algorithms that are all capable of taking an input and encrypting it, well, then you can combine those together without needing an extra layer.
Well, that makes some assumptions about the mode that is being used.
That's true.
Point out, so we did in that encryption part, we are making, yeah, we're using key shares so that each of the primitives is signing or encrypting rather a block that's the same length as the original content encryption key. So I don't think it's not like we're talking about like you're not going to have the message getting larger as you do more encryption or anything like that.
Right, but if they had different block sizes, you would have a different issue here.
But I guess if the KEK was encryptable with the public key before, it will be able to encrypt what's being asked of it here too.
Wow, I think we need to have a significant discussion of these three choices.
That's why I want to float. That's why I want to.
Right, I don't think you're advocating support for all three. Is that right?
I don't know what I'm advocating. We've done design work. I want to put it to the group and start a discussion. The core question to me seems, do we need in a post-quantum world to implement key trans recipient info? Or are we okay to only implement key agree? I think that's really the core question here.
Well, I think that ties back to the Chem for PKIX document and Chem for CMS document. You know, is that going to fall into agree or trans? John?
I was going to say, I think we do need key transport if we're combining it with like an RSA, right? So if you have an RSA and a Chem PQ algorithm, then you do need the key transport. And obviously the last one, more for chems, or for like ECDH or something, if you're doing that with classic and post-quantum too. So I think you do need 1 and 3, and 1 and 2 are really, 2 is more of a more generic of number 1. So it's basically just those 2. But yeah, I don't think we're going to solve that here today. So,
Yuri?
I am not sure you really need to consider RSA as a special case incompatible with post-quantum chems. I think the framework would deal exactly the same way with either. The fact that under the hood computations differ shouldn't matter.
yeah, I suppose you could use RSA Chem too underneath the hood, and then just default to number 3. So yeah, it's probably possible to just do 1.
Okay, I think at this point we'll cut it off the discussion and take it to the list. I've enjoyed this discussion and I've learned a few things. I hope that others have too. And thank you to the people who volunteered to start documents. So please update those and start the discussions where there is choices to be made so that we can adopt documents. All right.
Thank you very much.
Tim, any last words?
Thanks, everyone.
All right. Take care.
Thanks, Russ. I'll send you the notes that I've taken, and I can try to figure out how for next time how to use this note-taking tool.
All right. Thank you, John. I appreciate it.
Thanks. Take care.
Bye-bye.